water is a universal solvent and it is essential for all living organisms. We all know that water is colorless, odorless and a tasteless liquid. The water which reacts with highly electropositive metal such as sodium, potassium, etc. it gives rise to the liberation of H+ ion. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called hydrocarbon. Under that, we have discussed about the physical and chemical properties of dihydrogen, and also we have discussed about the uses of dihydrogen, and also we have talked about the hydrates and their type. Today, let us move on to the next topic of this unit about the introduction to the water and structure of water molecule in gas phase and physical properties of water and chemical properties of water. So now let us see what is a water and what are the sources of water. We all know that Earth atmosphere consists of water, most essential requirement for all living organism. Is it right? So it is known as universal solvent because it will dissolve almost all the substances in it. That is why we can say that water is a universal solvent and it is essential for all living organism. And we know that the water which is also abundantly found in the Earth biosphere. Is it right? Yes. And the human body, that consists of 70% of water, and all the animals and vegetable matter which consists of water. And plants will consist of around 50 to 95% of water. So remember, we know that water is also known as a universal solvent, but in human body, if you consider the water level, it consists of around 70%. When it is in the green plant, especially 95% of water will be there in the green plant, which will be involved in photosynthesis. So by this we can say that water is very much essential for all living organism. Okay, and we all know that how do we obtain the water from the different sources, especially the well, lakes, river, ponds, ocean are the main sources of water. Now let us see the estimated water safety supply in the different areas. That is, here I have listed out the different sources of water and their percentage also it is there. So from the ocean we can expect 97.33% of water. Similarly, from the saline lakes and from iceland seas, we can expect around 0.008%, and from polar ice and glaciers we can expect 2.04%, and from the groundwater we can expect 0.61%, and also from the lakes we can expect 0.009%, and from soil moisture we can expect 0.005. Similarly, from the atmospheric water vapor we can expect 0.001%. Similarly, from the river we can expect 0.001%. This is how the estimated world water supply that shows that the different sources of the water which yield a different percentage. So, hope you all understood with the estimation of the water all over the world supply. Next, we are going to understand the structure of the water in the gas phase. Okay. In a gas phase, the water molecules will be present in bent structure and it having a bond length around 104.5 degree. So you can see that in a water molecule, there are 2 hydrogen will be attached to the oxygen atom, and it consists of how many lone pair of electron? 2 lone pair of electron. Is it right? So that is why we will write the structure like this, and it has a bent structure, and the bond angle between the 2 hydrogen atom is 104.5 degree, and also the bond length will be measured around 95.7 picometer. So this shows that the water molecules will be exist in bent structure in the gas phase, and it consists of 2 hydrogen along with 2 lone pair of electron. The bond angle 104.5 degree. And remember, water molecule is highly polar in nature. Okay. Next comes to the structure of water, especially in the solid state. Okay. We know that water will be exist in solid state, that is in ice form. Is it right? Yes. So the ice is highly ordered 3D hydrogen bonded structure. Each oxygen atom is surrounded by tetrahedrally 4 oxygen atom at a distance around 276 picometer. So this is the structure of the water on the solid state, that is in the ice form. The structure of the water will be looks like this. You can see that these are the vacant spaces, or you can say that these are the interstitial site which are present in water molecule, and you can see that the hydrogen bonding which is also occurs between 2 oxygen atom as well as with a hydrogen atom. Okay, this shows that it forms a tetrahedral structure with other 4 oxygen atom with other 4 hydrogen atom. You can see that this is a tetrahedral structure of the oxygen molecule which is there in the water molecule. Remember, in water molecule also it consists of vacant spaces which is also known as what? Interstitial site. But we all know that always when you dissolve the ice cubes in a water, it will float over the water. Do you know why? Because the density of the water will be lower than that of the water. That is why the ice will be floats over the water. So this is the structure of the water in the gas phase as well as in the ice form, that is in a solid state. Next is physical properties of water. We all know that water is colorless, odorless and a tasteless liquid. Is it right? Yes. It feels wet and dissolve nearly everything. So when we feel the water, we feel very wet, and we know that water is a universal solvent. It can dissolve almost all the substances in it. It exists in a 3 form, that is, it can exist in a solid, liquid as well as in a gaseous form, and it can be reversible processes also. And it absorbs a large amount of heat and strikes together into the beads and drops, and it flows and erodes the surface of the earth, and it moves the sediments to form up beaches, river banks and bars. So these are the main physical properties of the water. Okay. Next we will understand the chemical properties of the water. Under that we are going to understand amphoteric nature of water. We all know that amphoteric substances are those which behave like both acid as well as the bases. Here our water itself can behave as an acid as well as the base form. Let us understand the reaction now. The water can react with the Bronsted acid as well as some of the Bronsted bases. This dual nature is known as amphoteric nature. The amphoteric compounds can act either as an acid or bases. You can see here hydrochloric acid is an acid, when it is reacting with the water, here the water will be act like a base and give rise to the hydronium ion, which give rise to what? Hydronium ion. By accepting the one of the proton from the HCl, it forms what? Hydronium ion with the liberation of chloride gas. This shows that our water molecule which are behaving like a bases. Similarly, when it is reacting with the ammonia, which is a base, our water will be act like a acid and it forms a NH4 plus ion with the liberation of OH minus ion. Here NH4 plus ion is a ammonium ion with the liberation of hydroxide ion. This shows that our water which behaves like a acid as well as the bases, this shows that our water will have a amphoteric nature, which means to say that when it is reacting with the acid, it behaves like a basis. When it is reacting with the bases, it acts like a acid and gives rise to the respective compound. From this, we can easily say that water will be act like amphoteric substances. Okay. Next is self-ionization of water. So what does it mean? It is another example for water which is being able to either to act as an acid as well as the bases. The molecules in the pure water which is continuously collide with each other, and this reaction shows that one molecules of the water reacting with another molecules of the water and results in a formation of hydronium ion as well as with the formation of acid. So this shows that water can also undergo self-ionization and one molecules of the water can accept one proton from the another molecule and give rise to the hydronium ion. Similarly, another water molecule can loses its proton and get converted into hydroxyl ion. So this indicates that the water molecule can easily undergo self-ionization. So hope you are understood with the self-ionization and amphoteric nature of water. Okay. Next is reaction which are involving in water. The water which reacts with highly electropositive metal such as sodium, potassium, etc. It gives rise to the liberation of H plus ion. Here you can see that when water reacting with the metal known as sodium, it forms what? Sodium hydroxide with the liberation of hydrogen gas. This shows that the water can reacting with a highly electropositive metal and leads to the formation of reduction of the metal in the form of sodium hydroxide. Okay. And during the photosynthesis also, water will be oxidizes to oxygen. Here you can see that the carbon dioxide reacting with the water molecule, we know that this reactions will be taking place in presence of sunlight and giving rise to the glucose with the formation of water molecule and also with the formation of oxygen. This process will be absorbed in a green plant during the photosynthesis. That is why green plant during the photosynthesis, it liberates the oxygen and that oxygen will be utilized by all living other organisms for their survivability. Okay. Next is highly electronegative element can also react with the water and results in a formation of HF. Here you can see that fluorine is a highly electronegative element. When it is reacting with the water molecule, it forms what? HF, that is hydrogen fluoride will be formed with the formation of oxygen. This indicates that the highly electronegative element known as fluorine get oxidized by the water to form a hydrogen fluoride. So this is how the water molecule can also involve in many other reactions and give us to the different product. Next is hydrolysis reaction. The water has a strong hydrating tendency due to the high dielectric constant. It dissolves many ionic compound, many ionic as well as with the many covalent compounds. So it will be easily get hydrolyzed by water. Here I have an example for this. to show that how hydrolysis will be done with the ionic compound as well as with the covalent compound. So here I have a P4O10 plus 6 water molecule give rise to the phosphoric acid. So similarly, silicon tetrachloride reacting with water molecule which forms what? Silicon dioxide with the liberation of HCl gas. Similarly, the nitrogen which is having 3 electrons and which is allowed to react with the water molecule, it forms ammonia with the formation of 3OH. This indicates that our water molecule can be easily used as a hydrolytic agent to hydrolyze the covalent as well as the ionic compound. Next is hydrate formation. So already I have explained that what is an hydrate. Is it right? Yes. How does the hydrate which is also formed with a water molecule? Let us see now. Many salts can be easily crystallized and hydrated salts from which aqueous solutions, the association of water molecules during the formation of hydrate salts will be taking place in a different way. Here you can see that I have listed out the 3 examples. One is coordinated water, interstitial water and hydrogen bonded water. In coordinated water, you can see that the chromium which is having a ligand known as water and forming a bond with the chlorine. So it is hexa-aqua chromium chloride. So our water will be act as what? Ligand in the coordination compound or in the coordinated water. Similarly, if I say it as interstitial water, remember in barium chloride, our water molecule will be goes and occupies at a empty spaces or in the vacant spaces to form what? Interstitial water. Coming into the hydrogen bonded water, you can see here copper with the water molecule with the SO2 2- ion. This shows that the water molecule will be forming hydrogen bonding with the copper, or you can say that water molecule having a hydrogen bond. This indicates that when copper, when it is dissolved in a water, which gives the blue color. When you remove the water content from the copper sulfate, it will become white in color. This shows that the water will form a hydrogen bonded in a water molecule. This is how we can easily understand that how our water molecule can also form a hydrate when it exists in a 3 different states. So in the next session, we are going to understand more about the hard as well as with the soft water. By this, I like to say that today I have done only with the water physical property, the structure and their chemical property. So in the next class, we are going to understand more about the hard and the soft water. Whatever I have done, have a look on it and try to work out with the chemical properties of the water. Till that, take care, be safe. We will meet you with the next session. Thank you.